Hey, in this video we are going to discover the obstacle avoidance steering behavior. As you can see here, we have a vehicle represented by that cone mesh and a path created out of a couple of checkpoints. Having said that, if you don't know what is a vehicle or how did I create this setup, I highly recommend you watch the first video of the Yuka Tutorials playlist. I'll leave you the links to both the video in the playlist in the description below. So the first thing we are going to do is create a handful meshes to set as obstacles. To do that, we'll just create 3 boxes and place them on top of the path. Now, as you can see, our vehicle goes through these obstacles because they are just mere meshes. They are still not considered as sort of real physical objects, if you will. So, what we are going to do next is create an entity and put it at the same location of the box, and that's done by calling copy from the game entity instance, which copies the position from the mesh that is set as argument. By the way, we can call the setRender component method to attach each game entity to a box, but since we are not going to animate and reposition them, we can manually do that this way. The next thing we need to do is to put these 3 game entities in an array, which we need to pass as argument to the constructor of the obstacle avoidance behavior class. Then we'll add that instance to the steering property of our vehicle. And now, even though we created the entities that represent the obstacles and added the steering behavior to the vehicle, we still have the same problem. To solve that problem, we need to understand something first. In order for the obstacle avoidance behavior to work, we need to get the limits of our entities, which are both the vehicle and the obstacles. That way, the vehicle will know when to start moving away when an obstacle is on its path, and it will be able to know the distance it should keep between it and the obstacle, and also when it should go back to the path. So back to the example, to get the information about that kind of invisible wrapper, we need to do a couple of things. The first one is to call the compute bounding sphere from the geometry of the mesh. Next, we'll need to pass that data to the vehicle instance property bounding radius. Keep in mind that if we don't call compute bounding sphere, this will not have any data, thus the steering behavior won't work. Now, of course, we need to apply these 2 steps on the 3 obstacles we have. Lastly, sometimes the vehicle can have some weird shaky movements like this example. I'm not sure though if you can notice it since the video is laggy, but I'll leave you the link to the project files so you can try it out by yourself. That being said, to fix that we need to set a value to the smoother property of the vehicle. That value must be an instance of the smoother class, and the value of the argument here depends on the case. I did some testing and 30 seemed fine for this example. And that's it for this tutorial, so make sure to like and subscribe, and I will see you in the next one.